going to get into the harder cases. Right? Using long division and then eventually synthetic division, which is sort of a shortcut to long division. But long division first. It's the same long division process that you would do if you're just dividing numbers. But now we're going to divide polynomials. And hopefully you've seen this in an algebra class before. All right, now, the one I'm going to use is the first expression here. But I just want you to be aware of this division expression. This is sort of the long division expression, is equivalent to the same as saying x cubed minus 5x minus 7 divided by that x minus 2. It's the same as using that division symbol. So just so you know, those are all three ways I can write my division symbol. And so I want to divide my x cubed minus 5x minus 7. And what you'll notice here in my expression, this is the way we usually start out. We write it like this. This is what we're dividing. But if you'll notice my first expression here, there's an extra term. And the reason why is I have to have a placeholder. It's kind of like when I have a number and there's a, 108, right? 108. Well, there's a 0 between the 1, right? If I have 108. Well, I say 100, this represents the 1, and I say 8. 0 is a placeholder between the two. And the same thing here with this cubic function. There are always all of the parts, right? When I have a degree 3, there is a degree 2 term, a degree 1 term, and a constant term. And if they're not there, I have to put in a placeholder. I have to put in a 0 as a placeholder. And so that's what this example is going to show you in order for the division to work. All right, so that 0 is a placeholder. So I'm going to rewrite this. So this is where you usually start, and then you recognize there's no square term. And I actually have to have a square term in order to do the long division. So I have to make sure I've got a counting down of the degrees. So if I start with a third degree, I've got to have a second degree, a first degree, and a constant. If I started with a fourth degree, I'd have to have a fourth, a third, a second, a first, and a constant. All right, so first thing we do is I'm going to rewrite this as my x minus 2 divided by x cubed plus 0x squared. There's my placeholder. Minus 5x minus 7. Alright, so remember, division is undoing a multiplication process. That's what division is. What did I multiply to get this expression? Alright, and I want to undo the multiplication process, right? 12 divided by 4 is 3, because 4 times 3 gives me 12. Same idea here, and so that's the mental process that we use. I need to know what number can I multiply my x term by. So I look at my leading term here, my x terms. This is the one I'm looking at. And this is the one I'm looking at. What can I multiply this x by to get an x cubed out? Well, I multiply by an x squared. And then I literally do that, right? And just think about it, it's undoing the division. If I take x cubed and divide by x, I'm left with x squared. That's another way you can think about it. I actually think it's easier to think about it in terms of multiplication, but that's the idea. X cubed divided by x leaves me with an x squared, right? Because that's what I have to multiply to get x cubed. And now that's what you literally do. In this step here, you're going to take your x squared and multiply it by your divisor, your x minus 2. And so when I do that, I'm going to get x cubed, which is what I wanted. And then I'm going to get a negative 2x squared, which is why I needed this placeholder. Because I can only add like terms. I can only subtract like terms. And that's my next step in the process. I'm going to subtract what I just wrote out. Right now I'm going to do a subtraction step. So now my next step is to subtract that to get rid of the x cubed. So this zeroes out, which is what I wanted. I needed the 0x squared here because I can only add like terms together. I can only subtract like terms. So I take 0x squared minus a negative 2. So remember, it's minus a negative 2. So minus the negative really means the positive 2x squared. All right, now we don't usually write the 0 there. I'm just writing it there to show you. And now I've done the first step in the division, the long division. My second step is, well, now I drop down my next number. So I'm going to drop down my negative 5x, and then I go through the process again. My first question, again, I look at my term here and I look at my term here, my mental process is, what do I multiply this x term by to get it to be 2x squared? Well, in order to get my x term to be 2x squared, I have to multiply by a 2x. So I write plus, you have to have separated by pluses and minuses, 2x. Another way to think about it is, I'm doing the division, right? If I take this 2x squared and I divide by the x, well, one of those x's cancel out, and it leaves me with a 2x. That's what we're doing. And now we actually do the multiplication step. So my next step here is to take my 2x, multiply by my x minus 2. So again, I'm going to get 2x squared, which again, that's the goal. That's my check that I've set it up right. And then I take my negative 2 times my 2x to get negative 4x. All right, now I subtract those, so that zeroes away. And remember, I'm subtracting. So it's a negative 5x minus a negative 4x. So it's really a negative 5x plus 4x. And so I'm going to be left with a positive x. Which again, I'm putting the 0 just so you can see what happens. But you don't really need that. All I'm left with is a positive x. And then I drop down my constant. All right, my last step then is, well, x is just x, so when I get x, it's just a 1, right? If I divide x by x, I'm left with 1, so there's a 1 here. Sorry, I missed a negative. I was talking and I missed a negative. Negative 5x minus a negative 4x should have left me with a negative x, right? Negative x. Because negative 5x plus 4 leaves me with a negative 1x. So there's a negative, so I missed this negative here, make sure you write it in. And so now, instead of having a 1, it's going to be a negative 1, right? What do I need to multiply by this x to make it a negative x? Well, I need to multiply by a negative 1, so my next step is to write out my negative 1. And then do the multiplication, right? Take my negative 1 times x minus 2. And so I get negative x plus 2, right? Negative 1 times negative 2 gives me a plus 2. I do my division, I do my subtraction step. And so again, that's going to 0 away. It's a negative 7 minus a 2, right? Negative 7 minus 2 is going to leave me with a negative 9. And then I'm done, because there's an x, I can't take 9 and divide it by x, so I'm actually left with that. And so what this last piece here that I'm left with, this is my remainder. Right? Whenever you do long division, once in a while you're left with a remainder. Well, a lot of times in division of polynomials, that's what we're going to be left with. All right, and so the answer is, I have my remainder, which actually we write our remainders up here as negative 9 over the x minus 2, what I'm dividing by. That's my remainder. And so my answer, I'll see it all, is this leading term, this term up here, x squared plus 2x minus 1, x squared plus 2x minus 1. And then I've got a negative 9 divided by x minus 2. That's the remainder part, right? I was left with a negative 9. Now you can either do it as a plus or a minus. You can do it either way. So plus a negative 9 or write it as the minus. Again, either way is fine. And so that is what the x cubed minus, what's my original expression? Minus 5x minus 7 divided by x minus 2 divides into. So it doesn't divide nice and neat, right? It doesn't leave me with a nice and neat number. I had a remainder left over. And so it divides into x squared plus 2x minus 1 with a remainder of 9. Right? So I have a 9 left over. And so what this expression is, this is the relationship that we get. And so this relationship is the dividend, divisor, quotient, and relation, the remainder relationship. And so when we write it out, it's the dividend, that's the number I'm dividing into, or the expression I'm dividing in, divisor equals the quotient. Quotient is the the expression I get when I do the division. And then sometimes we're left with a remainder. And we always take that remainder and divide it by the dividend. Or divisor, not dividend, sorry. Divisor. Alright, and there's two ways to actually then write it. That's one way. And the other way is, see how I have divisor under both of those? Well, I could multiply by my divisor and I can get the dividend equals the quotient spell it right, quotient times the divisor plus the remainder. That's the second way. And actually the second way is the one we like to write it in. Alright, so using the example I had above, which I wrote it in the first form, alright, there's my dividend is the x cubed minus 5x minus 7. The divisor is the x minus 2. The quotient I got is what I get when I do the division. X squared plus 2x minus 1. negative 9 was my remainder, and then I divide by the dividend. And so an alternative way to write that is the x cubed minus 5x minus 7, when I multiply through everything by x minus 2, my quotient, times the divisor minus the remainder, which, like I said, the second form is the way we like. So that's the relationship between the polynomial that I'm dividing into, that's the dividend, the polynomial I'm dividing by, which is the divisor, the x minus 2, the quotient I get when I do my division, that's the x squared plus 2x minus 1, and then if I have a remainder, then there's the remainder that's tacked on at the end. Alright, and so that's the relationship between the divisor, the dividend, the quotient, and the remainder. Right? There's four identities we always have. And there's two ways that we can write it. Again, this would be the way we get when we're doing it literal. This is what it is. And then we rearrange it because we like this form here, the second form. Alright, and so that's the relationship between the dividend, the divisor, the quotient, the remainder. Those are the two ways that we can write my four identities that I get when I do my long division. And we're just going to practice this more. We're actually going to do one more example of long division, and I'll do it in my next video. And then we're going to get to synthetic division, which allows us to do division of polynomials a little quicker. It's a quicker algorithm that we use. But both methods are fine. Long division is fine, and the synthetic division is fine. Alright, so we'll get to that in the next video.